This semester we had the pleasure of taking an extremely interesting course on information retrieval. Throughout the semester, our team worked on building an IR system, and this video summarizes our work. We have 5 team members in our group. Elvira conceptualized the overall function of the IR system, Naeem performed the crawling task, Jeff worked on the classification, Boontek and Gibson worked on the indexing and querying part. We use Twitter as the source for our document corpus because it is one of the most popular social media platforms where users express their opinions. We gathered more than 10,000 unique tweets that contain certain food keywords, and we built an IR system that analyzes the popularity of different food items on different days of the week. A Python script was written to retrieve tweets via Twitter API. The metadata of obtained tweets specifies the date and the keyword term. This facilitates the processing of tweets at later stages. We wanted our IR system to not only count how frequently a particular food item is mentioned on different weekdays, but also how well that food item is received by Twitter users. To do that, we classify the tweets into positive, neutral, and negative ones. Tweets, unlike formal articles or news posts, have fluid sentence structures. So we manually labeled 1,000 tweets for greater precision and accuracy. For example, a user can say, "I hate Mondays and I need pizza right now," and that tweet will be correctly categorized as positive in spite of the word hate, which has a negative sentiment. We used a combination of 3 techniques: unsupervised feature learning, SVM classification, and text preprocessing. Little domain knowledge was required because it was learned from the text itself. It means that with more training samples, the results should be dramatically better. This results in greater performance despite a limited number of samples and computational resources. For the pre-processing, we removed irrelevant hashtags, ads, URL links, downcased tweet text, transformed the text of the subject we're interested in, transformed emojis to words, and removed stop words. Text was transformed into a fixed length vector using paragraph vectors, and unsupervised feature learning, which utilizes a multi-layer feed-forward neural network which attempts to learn vector values that best describe the text. To optimize performance for SVM classification, normalization was performed on the float vectors. We then added a little noise to those vectors, altering 1 in 20 values by up to 0.2. It is seen that this would improve the generalization abilities of the SVM. These vectors were used to classify for sentiment by running through the SVM. Apache Solr was used as the backend's main search platform. Our IR system supports 2 types of queries, based on a weekday or based on a food keyword. Weekday-based queries look at the trend patterns of the food items in a single day of the week. Item-based queries look at the trend patterns of a certain food item across the week. When a query is received, we first remove stop words using a length filter, then correct spelling errors based on the threshold of 1 edit distance. Then the query is analyzed to identify the type of query based on keywords, which may be a weekday or a particular food item. Based on the query analysis, a set of results is built. Then the results are visualized graphically to help the user easily see the trend patterns. After the query is received on the front end, it is transformed by JavaScript into a suitable syntax and passed into Solr. Once the necessary information is retrieved, we present it on the front end in 2 sections, frequency and sentiment. By making frequency and sentiment viewable in both tabular and graphical forms, Our system allows easy comparison of statistics across various instances of the search results. Collectively, inferences on public opinion or population sentiment regarding a particular issue can be drawn from a large number of tweets. Our IR system allows users to study popularity trends of specific food items for commercial and research purposes. We would like to thank our Prof. Eric for a great course and for taking the time to view this video.